Hey, quick update. So this is a Axial Flux motor, and the cool thing about this design is that you get a very direct path of the flux from both sides of the coil of wire in your motor. And this is as opposed to your radial flux motors. This is something that I took out of a hoverboard. And you're only, when you have your coil of wire, you've got an entire portion of that coil, that magnetic moment, that's not actually generating torque. It's just going back through the transformer steel, and it's going to some other core that has an appropriate magnetic moment to complete the circuit, basically. And the problem with this is that if you're relying on the transformer steel's saturation headroom to get to a point where you can actually use torque from each of these coils and the phases changing on each of them. And once you run out of saturation headroom, there's nothing left to transmit through the actual steel. There's a certain limit to how much current you can actually pump through. And it's going to be a harder wall because you only have one side of that loop of wire that's generating that magnetic moment actually generating torque. And this is sort of what this design does considerably better. Now, you might be wondering how I constructed this. This is just using these laser cut steel slot joinery type things, and they're all just micro TIG together. And the cool thing about this design is that you get like a solid core. And now you might be thinking the solid core is bad if you have an experience with motors, and it really depends. It really depends because with laminates, sure, you have like a little bit less eddy current issues because you've got these steel laminations and some sort of insulator or air or something between each of these slots, but that's volume that you're not actively using for more magnetic material. And so you're basically losing somewhere between 3 to 7, I just say 5% as shorthand, of your total magnetic saturation threshold, saturation value that you have for transformer steel. So for this transformer steel, it's like 2.1 Tesla, give or take, you know? You're going to have a little bit less than that when you're making these stacks of laminate steel, because you're going to have, again, that air between each of those gaps. And so basically, this is great for high speed. At high switching speed, you're not going to have any issues with eddy current losses, really, in any significant capacity. But at lower speeds, you get like basically a free 5% of total magnetic saturation headroom. And basically, this motor is intended to only be driven to around 1,200 RPM. And, you know, if you put a 10-to-1 gearbox on that, you're still at 120 RPM, which is a full revolution per second. If you're building limbed robots, a full revolution for a joint every second, 2 full revolutions for a joint every second is it's plenty, honestly, especially for something that's around humans that you need to be safe. And yeah, this motor itself, based on my calculations, minus any weirdness, it'll probably have about 2 Newton meters of torque. Gives you kind of an idea of like the amount of force that this thing has. So really impressive, honestly. That such a small package will probably make pretty high torques. I'll be giving actual test results pretty soon here, but just wanted to show you what I've got here, and yeah.